The University of Wisconsin-Stevens Point Northern Aquaculture Demonstration Facility, in cooperation with Lac du Flambeau Indian Tribe and Wisconsin Sea Grant, presents Pond Culture, an online workshop. The online portion of this workshop has been organized by Greg Fisher, Facility Manager of the UW-Stevens Point Northern Aquaculture Demonstration Facility, Emma Wierma, Aquaculture Outreach and Education Specialist for the UWSP NADF facility, and Larry Woronowitz, Natural Resources Director for the Lac du Flambeau Band of Lake Superior Chippewa Indians. We will quickly highlight the expertise utilized in creating this workshop. My name is Emma Wierma. I have a degree in ecology and environmental biology and have had experience working in outreach and education throughout my career. Some of my past experience includes K-12 education, project coordinator for the Alliance for the Great Lakes, and webpage development. I currently work as a UWSP NADF Aquaculture Outreach Specialist as well as a research assistant. Through the facility, I have gained experience in rearing techniques and management practices for a number of cold and cool water species at all life stages in a variety of systems, including the facility's 4 half-acre clay-lined ponds. For this online workshop, I will be presenting 2 of the 4 PowerPoint presentations. Greg Fisher has been rearing a variety of both cold and cool water fish species for over 25 years. At the UWSP NADF, species are raised from egg to grow out in flow-through, pond, raceway, and recirculating aquaculture systems. The facility has 4 half-acre outdoor ponds for mainly production of walleye from fry to small or extended growth fingerlings. These ponds are drainable with an external catch basin for harvest. The facility utilizes the ponds for research and demonstration projects on topics such as fertilizer performance, aeration systems, fish densities, and pond production capacities. This research and demonstration by the UWSP NADF has benefited the pond aquaculture industry throughout the Midwest. Greg will be presenting the other 2 of the 4 PowerPoint presentations of this online workshop. Larry Woronowitz is the Natural Resource Director for the Lac du Flambeau Band of Lake Superior Chippewa Indians. Through Lac du Flambeau's Tribal Fish Hatchery and the Tribal Natural Resources Department, the tribe has been raising fish since 1936. They have a state-of-the-art fish hatchery, associated ponds, and raceways. The primary species raised from fry to fingerlings include walleye, muskellunge, white suckers, lake sturgeon, and trout. Walleye and muskellunge fingerlings are raised in fish culture ponds to stock waters located within the exterior boundaries of the Lac du Flambeau Indian Reservation. The reservation has 260 lakes and 71 miles of creeks, rivers, and streams. The fish raised and stocked help support both the subsistence and sports fisheries in these waters. Utilizing the expertise of the UWSP NADF, Lac du Flambeau Tribal Hatchery, as well as various other credible hatcheries and resources, we have organized these training modules to provide an introduction to pond culture for the Midwest region. The University of Wisconsin Sea Grant program has provided funding for this project. Thank you to all of our partners who have made this possible. In this 4-part online lecture series, we will discuss the general topics associated with pond culture, as well as a basic knowledge on the biology of pond-cultured fish in northern climates. Predominantly, walleye will be the main species discussed. We may also touch on some other species such as yellow perch, bluegill, and baitfish during this lecture series. Ponds play an important role in commercial aquaculture as well as sport fishing. This lecture series will provide a breakdown of general management practices involved in this method of aquaculture. So let's get started. Welcome to the online Pond Culture Workshop. This workshop consists of 4 PowerPoint online lectures which lead into a final hands-on training opportunity at existing facilities. These 4 PowerPoints are divided into general topics concentrating on pond construction, pond management, water quality, fish management, as well as a basic knowledge on the biology of pond-cultured fish in northern climates. Welcome to the first lecture of the online Pond Culture Workshop on pond construction. Within this topic, we will discuss an overview of pond culture, including the advantages and disadvantages, the various pond types to raise fish, pond draining, and fish harvest from ponds. First, let's highlight the importance of pond culture in Wisconsin. Ponds serve as a great resource for aquaculture. While intensive rearing of fish is gaining in popularity throughout North America and is a promising technology, Many of our cool water species, such as walleye and yellow perch, are still reared in earthen ponds. Wisconsin has an abundance of water resources, consisting of approximately 15,000 inland lakes and countless ponds. Approximately 1.3 million acres of water surface area exist in the state. Although these are a great resource, there are specific permits and regulations that are required and govern the use of this resource. Pond culture is usually regarded as the most economical way to raise fish compared to other general methods. Because of this commercial benefit, most aquaculture in the United States as well as worldwide is seen in pond culture. There is a diversity of methodologies for management and fish culture that is employed by various agencies and the private sector. Although it is difficult to cover everything, we will attempt to give you a good overview and understanding of fish rearing in ponds with the following lectures. To reiterate, these lectures will be geared towards rearing walleye as a common target species, but many of these topics covered will be useful for other cool water species commonly reared in the Midwest. It is important before investing time and funding in pond culture to fully understand the limitations and expectations of the pond system you are utilizing to produce fish before beginning. It has been said many times that pond culture is an art, not a science, and what works in one pond may not work in another pond. We hope you use these concepts and information in this outline course as a guide and apply them to your situation. Discussing the advantages and disadvantages of ponds is important for understanding the components of pond culture. One main advantage of ponds is the ability to raise fish at low densities due to the large volume of water. Raising fish utilizing water volumes in space, as compared to a tank or raceway, allows fish to be reared at lower density, which is a less stressful environment. Thus, fish reared in lower densities will typically have greater immunity to disease and lower disease transfer opportunity within the pond. Also, lower density reduces the chance for cannibalism to occur. Another advantage of ponds is their ability to contain and manage effluent that may pollute the environment. This is becoming increasingly evident as regulations become stricter. We mentioned previously that pond culture is probably the most economical method of aquaculture in Wisconsin. Additionally, ponds provide higher level of buffering capacity for operational or management mistakes, thus making them good starters for many beginning aquaculture personnel. On the flip side, pond culture does have its disadvantages. Due to rearing lower densities of fish, a large land area with an efficient supply of good quality water are required for a pond to meet high production goals. Another important consideration is the growth period available to fish in outdoor ponds. Many fish show optimum growth with higher temperatures. Therefore, there is only a seasonal growth period during the summer for fish raised in ponds in a northern climate. Increased predation by aquatic invertebrates, birds, or mammals is another disadvantage for rearing fish in ponds. Appropriate measures must be taken beforehand to prevent predation issues from getting out of hand. Also, when rearing fish in ponds, there is an inherent biosecurity risk, as with any outdoor system. Fish are reared in ponds most likely have some form of parasite or bacterial infestation that must be dealt with when removing these fish from the pond, especially if bringing them into an indoor rearing system. This is generally why pond-reared fish are not suitable candidates for indoor rearing systems due to biosecurity and potential performance issues. We will now move on to pond type and construction. There are two main types of ponds in Wisconsin: natural or constructed ponds. Natural ponds are existing water bodies that may require specific requirements for aquaculture use. Most natural ponds are considered permanent and are not drainable. Many of these natural ponds or lakes are much larger than constructed drainable ponds, thus management is more difficult. Specific permitting and regulations are in effect for both natural and constructed ponds for aquaculture. For simplicity's sake, in this module we are considering natural lakes and ponds to be fairly large and not drainable. Constructed ponds are mainly used in commercial aquaculture and may have less specific requirements for fish rearing. If the ground is sandy and permeable, these ponds are lined with plastic or clay in order to hold water. Some areas of Wisconsin contain higher levels of suitable clay for pond construction. Also, constructed ponds are generally smaller, more manageable, and often drainable, unlike most natural ponds. To highlight this point, the Walleye Culture Manual states that survival and yield for walleyes on Phase 1 fingerlings is greater in drainable ponds versus undrainable ponds. This culture manual is available by the North Central Region Aquaculture Center at ncrac.org. First, let's discuss natural lakes and ponds for aquaculture. These water bodies are generally fairly large, may or may not suffer winter kill, and require much different management and permitting than smaller constructed rearing ponds. They often fill slowly, utilizing snowmelt and runoff water. Often, natural ponds are deep and have woody material and vegetation that can create issues during harvest. Managing large ponds and lakes require different gear than smaller or constructed ponds. Generally, these water bodies are harvested with large seines or fyke nets, which are very labor-intensive. Pictured is a natural lake over 100 acres in size located in northern Finland. This lake is utilized by a governmental hatchery for rearing herring from fry to fingerling size. Millions of fry are stocked in the spring and grown all summer on natural food in the lake. This is an example of a very large natural water body that is managed for rearing fish. This is not a typical situation in Wisconsin. To summarize, natural lakes and ponds are unique and pose many challenges throughout the production and harvest season. In most cases, you do not have control over the fertility of the system due to the water supply, and usually are not drainable. The number of fish produced will depend solely on the nutrients and the water available, which is very hard to quantify and rely on. The second challenge is harvesting the fish, especially if the lake or pond is not drainable. Difficulties with non-drainable ponds include pond depth, stress on the workers and the fish, vegetation and woody debris to entangle the net, and vehicle access. Nets of various designs will be required to harvest the fish, which is difficult, labor-intensive, and expensive. Pond or lake owners often like to know if they can stock fish into their existing natural water body. It is important to understand that natural water bodies are complex and their conditions change continuously. Pond owners should note that pond surroundings and specific water quality parameters such as water temperature, oxygen levels, alkalinity, pH, nitrogen, and phosphorus levels should be known in order to fully understand their pond is suitable for fish or not. Also, special care must be taken to avoid contamination from substances like pesticides or high metals associated with other activities occurring in the watershed. For example, a pond located near a building with a galvanized roof can receive water high in metals that may kill young fish after a rain event. The use of herbicides or pesticides in fields due to runoff, overspray, or manure spreading can also kill fish under the right conditions. Different species of fish also demand specific water quality parameters. Knowing the biology of the species you are raising is critical to understanding how these parameters will affect production. These parameters will be discussed in more detail in the water quality section of this workshop. Working with a professional biologist is more cost-effective in the long run in understanding how your pond works and interpreting any water quality data that is obtained. We will now move on to the next pond type, constructed ponds. These are typically excavated or dug, impounded, or constructed with levees. Constructed ponds can be grouped into two different classifications, drainable or undrainable. Drainable ponds are very popular with many fish rearing groups due to the ability to manage, fertilize, and harvest large numbers of fish very efficiently, even though they may be more costly than natural, undrainable ponds. According to Bob Sommerfelt in the Walleye Culture Manual, survival and yield for walleye fingerlings is greater in drainable ponds compared to undrainable ponds. Most undrainable ponds lack water level control and may have excessive outflow of water, which could cause a loss of production or escapement. Conversely, they also may lack water input when it is most needed. This is again why drainable ponds are preferred due to the ability for better management overall. Due to this, we will concentrate on constructed ponds that are drainable for the rest of this lecture. If you are planning on constructing ponds for rearing fish, careful consideration on the location or siting of your ponds is crucial to maximize production and save costs. First, it is important to construct ponds in full sunlight to maximize photosynthesis levels, increasing production in the pond. Secondly, orient ponds to take advantage of any wind activity to help with oxygen levels and decrease pond stratification. Thirdly, understanding the topography and soil conditions are also important. For example, take advantage of clay soils with a 10 to 20% clay content, if possible, to save the cost of purchasing a liner for your ponds. Utilizing the natural topography to limit water pumping and aid in draining also may save on costs. Lastly, locate ponds near a reliable, pathogen-free water source that is adequate for meeting the needs that are required to fill ponds fairly quickly, or in 1 to 2 days. The next few slides will highlight some different styles in construction for both lined and unlined ponds. Typical drainable ponds are small artificial bodies of water with levees on 4 sides that are designed to grow fish. Harvest is typically done by draining the pond through a structure called a catch kettle or catch basin. When constructing a fish pond, there are many careful considerations. These include location, soil type, water supply, electrical supply, travel corridors, species of fish, sunlight orientation, aeration, fish predation, management plan, and harvest. The next few slides will discuss some of these variables. This slide shows an example of lined ponds with substrate applied over the top of the liner to assist with keeping the liner in place. This was done at the U.S. Fish and Wildlife Service Genoa Fish Hatchery in southern Wisconsin. Notice the entry road into the pond for maintenance work at Genoa Fish Hatchery. Here is another example of a lined pond complex at the Rathbun State Fish Hatchery in Iowa, without the use of substrate at the bottom. Notice the aerators in every pond. Ponds come in many different sizes. For example, here is a small lined pond utilized for bluegill production at the Rathbun State Fish Hatchery. Notice the internal fish harvesting kettle and steps leading into the pond. Pond construction can be a time-consuming and costly endeavor, so you need to make sure you understand the process, costs, and definitely plan far in advance. Are you going to hire someone to build your ponds or build them yourself? Using heavy equipment can be costly, and having enough staff to run it can be hard to find. Searching for a good construction firm that understands pond construction, specifically fish pond construction, can be worthwhile and save costs in the long run. Let's move on to the details of constructing a pond. A desirable size for constructed ponds is from 0.5 to 2 acres. A rectangular shape with a 2-to-1 length-width ratio is desirable for management. The bottom of the pond should slope slightly towards the drain and collection kettle to facilitate harvest. An acceptable bottom slope ratio would be around 0.5% or less, depending on the size of the pond. Understanding the correct ratio for the sides of the pond is important as well. Steep slopes can deter wading birds such as blue herons and can also limit rooted vegetation or weed growth in the pond. On the other hand, if slopes are too steep, they can be subject to erosion. Finding the right ratio for your soil type is critical so that the pond slides do not slough in over time. Typically, a 3-to-1 slope is utilized for side slopes in clay soils. There are reference books and agencies available to help with pond designs. The Natural Resources Conservation Service has experience with designing and installing fish ponds in Wisconsin. They will be listed as a resource at the end of this PowerPoint. One of the larger problems with pond culture is controlling aquatic plant species. Although plants provide habitat, cover, and nutrient removal, a pond can easily become overrun by plants, entangling fish during harvest. Many fish will then need to be picked by hand or lost in the vegetation. Having too many weeds will also decrease the volume of a pond, restricting room for high production levels. To deal with this issue, ponds can be designed to help control aquatic plants. A few ways is by minimizing the inflow of nutrients, keeping the bottom of the pond deep and dark, and constructing steep side slopes. Periodically, you may need to remove weeds by hand or through monitored use of chemicals. We will discuss means of control in greater detail in the pond fertilization module of this workshop. Here is a useful summary of pond design characteristics from the Walleye Culture Manual. We will highlight a few key points from this table. Starting with water supply, each pond should only take 2 to 3 days to fill. Each pond should also be 1 to 2 acres in size, having a rectangular shape with 2 to 1 ratio of length to width. The shallowest point is to be 3 to 4 feet deep, leading to a 4 to 6 foot depth near the drainage point. Although 6 feet is stated in the table, for Wisconsin ponds, depths may be increased for greater production capacity. To clarify, this depth is recommended for one production season, not to overwinter your fish. If overwintering, depths should be even greater to prevent winter kill. Another key point, according to Sommerfeld, is an outside or exterior fish collection basin is superior to an internal collection basin, which will be discussed later in the presentation. Draining the ponds can be accomplished many ways. One of the simplest designs for draining ponds is known as a riser and stop log construction, shown here in the top diagram. This allows for a controlled bottom draw-off in constructed ponds. A controlled, slow draining of a pond is typical and preferred when harvesting fish. Usually, the first 2 days consist of a partial draining when about 3/4 of the water is drained from the pond. After the initial draining, the remaining pond water is drained along with most of the fish. This is the final harvest period and should be planned to occur early in the morning when conditions are best. The bottom picture shows a less preferred surface overflow dam construction, which is mainly used for areas where runoff or inflow variations could be a problem. There is less control when draining ponds with this design, and ponds may drain too quickly. Moving on, let's discuss a few key points when draining your pond. The first, as we mentioned, is to drain slowly, which is less stressful on the fish. Generally, it should take 1 to 2 days to drain ponds down to prepare for the final harvest. Walleye, especially, are known to stay in the last quarter of the pond water, swimming down with the final water that is left in the pond. It is also important to plan accordingly for weather and other variables before harvesting ponds. Harvest should happen on a cool day in the early morning when temperatures are low. This is to help keep oxygen at a safe level, as well as keep stress down for both fish and workers. Lastly, always provide adequate fresh water and aeration while draining the pond, not only in the pond itself, but also in the collection kettle or basin. A simple way to harvest the fish from a pond is using a harvest funnel in the pond and a catch kettle outside the pond. The pictures show the base of a concrete harvest funnel to facilitate harvest. This funnel directs the fish and water from the pond into the drain piping leading to the harvest kettle, utilizing gravity. As we mentioned, utilizing the riser and stop log construction with an engineered design is ideal for controlled draining of a pond. Piping leading to the harvest kettle should be taken into consideration for fish size and distance between the pond and the kettle. Typically, a 10 to 12 inch diameter high-density polyethylene or HDPE piping is recommended. Although more expensive up front, HDPE piping is better constructed to handle frost heaves and high pressure without breaking. This is a less expensive option in the long run compared to using cheaper piping and having to go back and replace with HDPE due to problems. This recommendation is from past experience at UWSP NADF and other facilities that have encountered issues with cheaper piping alternatives. Here is another example of an internal funnel construction in more detail at the Flambeau tribal fish hatchery. The funnel consists of a concrete floor, chimney, wing walls, slide gates, and channels. Aluminum concrete forms are recommended to provide for smoother surfaces. If the pond is lined with rubber or plastic, the liner will need to be anchored to the floor and the wing walls of the funnel. Aluminum stop channels and screw gates are used to control the water flow. This slide shows the construction crew removing the forms from a finished in-pond harvest funnel. A rear pond levee will be built around this so that the funnel is embedded in the clay at the rear end of the pond. To summarize, the benefits of the system are as follows. Fish are easily transferred with little stress to the catch kettle with water from the pond. Very few fish are harvested directly from the pond by workers, which is much safer than carrying buckets or nets of fish up slippery stairs or pond bank. These points alone show that this system to be overall safer for both fish and workers than harvesting directly from the pond. This system can also harvest multiple ponds with one strategically located external catch kettle. Ponds can then be harvested quickly and efficiently by only a few workers. This slide shows a finished half-acre clay-lined pond with correct shape and ratios for optimum management. You can see the in-pond harvest funnel utilizing the riser and stop log construction. Notice how the bottom of the pond is sloping towards both the middle and towards the funnel to facilitate drainage and harvest. To prevent erosion, the steep sides of the pond will be seeded with grass. Now let's describe the external catch kettle. The pond harvest kettle, or catch basin, can be constructed from a variety of materials. We have seen fiberglass, wood, concrete, or even a kiddie swimming pool used. The catch basin allows for the fish to leave the pond and enter the kettle through piping via gravity. The kettle then strains the fish from the pond water so they are concentrated for harvest. Often, kettles are constructed from concrete with screens and dam boards to regulate water height and concentrate the fish. Think of a spaghetti strainer or colander. There are many different styles that can be utilized for this operation. Whatever the type utilized, a catch basin for harvesting fish increases the efficiency of harvest and reduces stress on both the fish and workers. A catch basin should be supplied with adequate aeration, fresh water, and electrical service. Clean water supply is absolutely needed during harvest. Also, little things like rounded corners and gentle bends with piping can make the difference in the health and quality of your fish coming out of the ponds. Here we are highlighting a rounded corner mold in an external catch kettle before the concrete is poured. The arrows in the smaller photo show that with a rounded corner, as the fish enter, they are gently directed around the kettle. This is the NADF external pond harvest kettle. This system can efficiently harvest 4 different ponds on separate days with only 2 to 3 workers. The kettle is equipped with a fresh water supply, air supply, safety railing, screening, walkway, and electrical power. With this system, walleyes ranging in size from small fingerlings to mature broodstock have been harvested from the ponds. Each pond is individually drained directly into the kettle. Fish are netted out, sampled, and loaded directly into hauling trucks. Just a few people can efficiently harvest a pond in several hours following a pre-draining protocol. We will go into more detail regarding external collecting kettles in the fish management portion of this workshop. This is an example of a large collecting kettle utilized for a lake over 250 acres in size. The lake is drawn down through this narrow funnel and flows into a constructed concrete catch basin with screens. It may take several weeks to fully drain this lake. The fish are then removed from the basin and loaded onto trucks for shipping. Another type of harvest kettle is located inside the pond, or an internal collecting kettle. The one being constructed here is at the Rathbun State Fish Hatchery. In contrast to the external kettle, the internal pond kettle does not utilize a harvest funnel, but rather drains directly into a concrete basin built into the bottom of the pond at the lowest point. When using an internal kettle to drain the pond, a valve is opened allowing for water to flow out through screens, keeping the fish in. As the water level drops, the fish are concentrated in the kettle where they then can be harvested. This photo shows an internal kettle after the pond has been drained. The fish are concentrated in the kettle ready for harvest. Like the external kettle, with the internal system, fish can be concentrated and harvested directly from the kettle. A few disadvantages of this system include the need for a kettle in each pond and limited accessibility to a hauling truck, which may be more labor-intensive, causing more stress for workers and the fish. On a different note, if ponds do not have a harvest kettle, internal or external, or cannot be drained, fish need to be harvested by the use of nets. Of course, the bigger the pond, the bigger the net. Various netting may be used, such as seine nets, shown here, or fyke nets. Netting fish from ponds is not only labor-intensive, but it is highly stressful on both fish and workers. Also, there is little guarantee that all the fish have been netted from the pond. In both drainable and undrainable ponds, fyke nets can be used for harvest. In Lac de Flambeau, hatchery crews set fyke nets to harvest walleye fingerlings, as pictured. The ends of the fyke net are secured near the fresh water supply. This serves two functions. For one, water attracts the walleye to the net, and secondly, provides cool oxygenated water to fish trapped in the net. Again, this harvest method is labor-intensive and does not completely harvest all the fish from the pond. An additional construction topic for drainable ponds is a sedimentation basin. In some pond management situations, in order to comply with discharge regulations, a sedimentation basin may be required. The purpose of this basin is to reduce solids before the water is discharged. The basin is located downstream from the ponds and harvest kettles, allowing the solids to settle out of the water by retaining and slowing down the flow of effluent. After the harvest season, the solids have to be removed from the sedimentation basin. When composted, these solids make great fertilizer. The above pictures show different construction phases of a sediment basin located in Lac de Flambeau, Wisconsin. Ultimately, this is what every pond manager would like to see at the end of the fish rearing season. Lots of healthy walleye fingerlings or other species going into the hauling truck. Hopefully, we have helped to provide some useful information in this tutorial regarding ponds and pond construction. Be sure and continue with the next tutorial on fertilization and water quality for ponds. Here are a few contacts for lining and designing ponds for fish production. This concludes the first module of the Pond Culture Workshop. We would like to acknowledge the resources and professionals that have provided information utilized for this module. We hope this helps you become a more effective pond manager. This module is meant to be an introduction to pond construction portion of pond culture management and is to be a prerequisite to further training. Thank you for your attention. Please continue to the second PowerPoint lecture on pond management.